All right, we've got a handful of math problems we need to be able to work out. If you look at your formula sheet in the upper left-hand corner of the page we've been working with, there's some formulas we haven't really been doing much with yet. And these are shown on the sheet in front of you and on the screen right here. And so these are terms we've been using before, and they're kind of just some of the previous formulas rearranged or put together. So we're not using anything different. If you've taken your notes already, you should see what all these things stand for. We've got V's with an I and an F because we're talking about motion. So things are speeding up and slowing down. We've got initial velocities and final velocities. We've had in our notes before, initial means that's what you're beginning with. Acceleration's A, that's us speeding up or slowing down. Displacement D is how far we moved, and T is time. So with all of these things put together, if you've got velocity, something is moving, that means time is passing, distance is occurring. If something's accelerating, then the velocities are changing, but at the same time, it's also moving, so the distance is changing and the time can be changing as well. So these formulas allow us to take certain word problems and to simply work them out. So I'm gonna work out a few of these, and hopefully some of the ones that I don't do, you will complete because you need to. And if you will use this method of how I'm going to show you, it makes it a little bit easier to make sure that you're not doing things wrong. Because one of the things you have to do is choose which formula to use. You have the reference sheet in front of you, but one of the big skills is looking at the formulas you have and figuring out which one you should use and which ones aren't going to work for you. So to begin with that, it's usually just kind of about paying attention to the problem and identifying what's there. So I'm going to go through maybe 3 or 4 of these with you of different problem types so we can see how to answer them and how to work them. The first couple are pretty simple. So let's read through them, and you'll notice we've given you a little table down here at the bottom so that you can list things out. So these are all the possible variables that might show up in the problem, but we're probably not going to use all of them. There's generally going to be something missing. So if you look up here in the box, you'll notice in each of the different formulas we have, there's something missing. And that's kind of another thing to pay attention to, because if we're trying to solve for D, we can't use a formula that's got a D in it. It doesn't work that way. And if you're trying to solve for D, for example, in this one, and we don't know T, then we can't use that formula. So if we're trying to solve for something over here, then we need to know all of the variables that we have over there. So let's read through this and fill in the chart, and then we can just do some quick math. I probably will just leave you to finish them up. But it says a car is moving at a velocity of 25 meters. And I know that might look a little bit different to you, but that's an negative exponent. So that basically means meters per second. And this one basically means meters per second squared. So it's moving at a velocity of 25. So we're going to assume that that's how fast it's going right now. So that's going to be its initial velocity. So if you're listing this out on your own, you might have to make your own chart, say VI equals 25. It accelerates at a rate of 6. So that tells us what the acceleration is. And then it says find its velocity. That's what we're looking for. So I'm going to put a question mark here. And then it says after 3 seconds, which is going to be the time. So the thing we don't have distance. We're trying to solve for final velocity. We've got a formula for final velocity that we can use if we know VI, A, and T. We know VI, we know A, and we know T. So now we just substitute everything in. So I'm going to set the thing up for us here, because it's, again, VF equals VI plus A. And again, this is like times T. If I substitute things in, VI, if we come down here, was 25. And then if we multiply A and T together, it's going to be 6 times 3. And then I'm going to leave you to do the rest of the math on this. But when you do all the rest of the math, that's going to be your final velocity. And again, your answer should be, in this case, meters per second, because that's what velocity is. All right. So if you need to check that out again, you can pause it, rewind it, do what you need to do. Let's see if I can remember how to clear all my drawings, and I do. That's good. So this is a find the velocity question. All right, so this next one is also a find the velocity question. So you would set it up the same way. There's 2 different ones to work on here. I'm not going to do this one because it's similar to the one before, because we're calculating the velocity. I am going to go down to this third one because it's a calculate the distance. And so we're going to have things looking a little bit different on this one. So number 3, let's read through it, see what we have, what our numbers mean. So if we're traveling a motorbike, so like a motorcycle, is traveling with a velocity of 3 meters per second. So that's its initial velocity. It's how fast we're going to begin with. It accelerates at 9.3, and it's for 1.8 seconds. And again, our units can be really helpful to help us remember what the variable is. Seconds are time, meters per second squared is acceleration, meters per second is always a velocity. And we're trying to calculate a distance. So this is what I don't know. And I don't have a final velocity. If you go back up into the formula sheet, I'm not going to scroll back and forth because that's kind of distracting. We can look at our formulas, and there is a formula that allows us to solve for D. And the formula is D equals VI times T plus 1/2 AT squared. If you're using your Desmos calculator, this makes it really easy because you can just type this into your Desmos calculator and you're going to get the answer. So VI times T, that's 3 times 1.8. I like to use parentheses a lot. It helps me to separate everything out. Plus 1/2. Now you can do this one of two ways. Hopefully you know that 1/2 is the same thing as 0.5. So if you're putting this into the calculator, you might just go ahead and change this to being 0.5. I mean, you could put 1/2, but this simplifies things for me. And then A is 9.3. And then T is 1.8. And what people often leave off is that that has to be squared. If you put all that in your calculator, you're going to get the right answer, and you're done. Okay. So again, the main task here is listing out all the things in the problem, identifying what it is that you're trying to solve for, and then after that, doing the math. All right. So I'm going to scroll down to number 5. Again, this one's a little bit different as well. All right. So this one says a bullet accelerates from rest at a rate of 90,000 meters per second. All right, so this is our acceleration. It's a big number. And it says from rest. So here's a thing sometimes when you're doing these word problems, that's not a number, but when you're at rest to begin with, that means your initial velocity is 0. So anytime we see the word at rest, we're going to assign the number 0 to that. Sometimes if it starts at rest, it's 0 for the VI. If it comes to rest, it's a 0 for the VF. Calculate the velocity. So we're trying to do its final velocity. If it travels a distance of 0.5 while accelerating. We don't know the time on this one. So we're trying to solve for VF. If you go back and look at your formula sheet, we do have a VF that we can use if we know VI, A, and D. So we know VI, we know A, and we know D. And this formula is probably the hardest one to use because it requires us to do one additional little thing. And I'll probably work this whole thing out. So the formula for this one's VF squared, and it equals VI squared plus 2AD. So we don't do anything differently as far as solving it. We're just going to plug some numbers in, but we got to pay attention to the squares, and that's where this one comes in. So VI squared makes it nice and easy because it's 0 squared. And then it's plus 2 times A, and that's our big number, 90,000. I'm going to run out of room. Times 0.5. Right. So 0 squared is going to be 0, so we don't really have to worry about that. So in your calculator, if you do 2 times 90,000 times 0.5, and I don't have the calculator up right now, you can do this on your own, you're going to get an answer. All right, that's not your answer though. So whatever number you get right here, I'm going to put the number sign. So you do the math on your calculator. When you get the number right here, that is not your answer because over here, this is VF squared. And we're not trying to answer VF squared, we're trying to answer VF. The way, and I'm going to use not really math language here, the way that you unsquare something is to take the square root. All right, so for us to go from VF squared to VF, we would have to take the square root to do that. Okay. Anytime we want to do something on an equation, we need to do the opposite thing. So if we want to unmultiply, we divide. If we want to unadd, we subtract. If we want to unsquare something, we have to do the opposite, which is to take the square root, which means that whatever number you got up here, you also need to take the square root of that number. Once you take the square root of a number, that is going to be your answer on that one. So this formula is a little bit different to use because you got to keep that in mind, that if you're solving for VF and you're using the VF squared formula, once you do all the math on the right-hand side, you've got one last step to do because your answer is for VF squared. We don't want that. We want VF. So we have to take the square root of both sides, which means you have to take the square root of that number. Okay. I would like for you to practice the rest of these. There should be some additional practice problems on the back of this that we'll work on for the next couple of days, and then move along from that. As always, if I can be of help, please let me know.